Bismillahirrahmanirrahim. Today our lab is implementing circuit of registers and counters. So the objective of our lab is learn how register and counter works, implement 4-bit register and implement counter circuit on software and hardware. So first of all we have to know what are registers and counters. So a register is a collection of flip-flops. A flip-flop is used to store single bit digital data. For storing a large number of bits, the storage capacity is increased by grouping more than one flip-flops. If we want to store an n-bit word, we have to use an n-bit register containing n number of flip-flops. So basically, a register is nothing but a flip-flops, a group of flip-flops. A single flip-flop stores a single bit number. So if we want to store a large number of bits, so we form a group of flip-flops and we call them a register. So a register is formed by grouping of flip-flops. A register is used to store a number which is any bits, 2, 3 bit, 4 bit, 5 bit and so on. So this is basically the diagram of a register, in which you can see that we have the 4 flip-flops attached. So we can call this as a 4-bit register which can store 4-bit number. After that we have counters. So counter circuit is usually constructed of a number of flip-flops connected in cascade. Counters are a very widely used component in digital circuits and are manufactured as separate integrated circuits and also incorporated as parts of larger integrated circuits. So a counter is same as the register, but bit different from a register. A counter is used to count the numbers. So if we want to count numbers, we have to know what are our previous numbers. So by using the flip-flops and a sequential circuit, we can make counters. So we can call counters as our sequential circuit, because we have to count numbers, and for to count the number we must know what are our previous inputs and our previous outputs. So counters are basically sequential circuit. So counters are nothing but to count numbers. After that we have the following types of counters, which are asynchronous counter and synchronous counter. So first of all we have the asynchronous counter. In asynchronous counter we don't use universal clock. Only first flip-flop is driven by main clock, and the clock input of rest of the following flip-flop is driven by output of previous flip-flops. So this is basically the diagram of asynchronous asynchronous counter. So asynchronous counter is a counter in which we give only the clock to the first flip-flop, and for the next flip-flops we use the output of previous flip-flop as a clock of the next flip-flop. So we do not have to give clock simultaneously to every flip-flop in asynchronous counter. After that we have the synchronous counter. The difference between asynchronous and synchronous counter is that in synchronous counter we have to give clock simultaneously to every flip-flop. And the basic logic diagram of synchronous counter, you see here I have given the diagram of a synchronous counter, in which we have the 4 flip-flops, and you see that clock is given simultaneously to every flip-flop, and we have the 2 AND gates attached here. So this is the synchronous counter. After that we have to implement the synchronous up counter and down counter. Synchronous counter I have already told you. So basically up counter and down counter. So basically up counter is a circuit which counts from 0 to maximum number, depends upon the bit size and state size. In 4-bit size we can say that in 4 bits the maximum number we can store is 15. So up counter is a circuit which can count from 0 to 15 in ascending order. First we have 0, then 1, then 2, 3, 4, 5 and up to 15. So this is the up counter which counts in ascending order. And after that we have the down counter, which is nothing but same as up counter but different in a way that down counter counts in descending order. Means that it can count in 4-bit counter from 15 to 1. First it gives the 15, then 14, 13, 12 and up to 1. So a down counter counts in descending order. The circuit of down counter is a little bit different from the up counter. So now we have to implement the circuits of synchronous up counter and down counter on Proteus. Now I have made the circuit of synchronous up counter and Proteus. You can see that it is the same circuit which is already given in the world file, and I have already shown you here all our 4 flip-flops because I have made the 4-bit counter. So here is the flip-flop A, then B, then C and D, and the output of the first flip-flop is acting as the input of the second flip-flop, and this is going in the AND gate. And you see that here the clock is simultaneously given to every flip-flop because it is synchronous up counter. And we have given the logic 1 always because we have to run the counter in toggle state, so we always given logic 1 in the flip-flops. And here you see that I have used 7-segment display connected to the output of every flip-flop because I am going to show you the output of a counter in 7-segment display. Now when I am run the circuit, I am going to run the circuit. You see that this is the synchronous up counter, so it starts counting from 0 and it goes from the up to 15 because it is the 7-segment display. So here we can see maximum number up to 9. After that we cannot see it on the 7-segment display, but it goes up to maximum number of 4-bit which is 15, and after that it starts again counting from 0 up to 15. So here you can see that it is our synchronous up counter which counts from 0 to maximum number 15. You see that when 15 arrives, it again starts from 0. Now it starts from 0 and again starts from 15. So this is basically our synchronous up counter. Now you see that I have made a circuit of synchronous down counter and Proteus. The states remain the same, 4 states. We have the 4 flip-flop. The difference in up counter and down counter is that you can see that here the output Q bar is going to the input of the second flip-flop and it goes to the AND gate. But in up counter you see that the output Q is acting as the input for the next flip-flops. So this is basically the difference between up counter and down counter. In down counter the output Q bar is acting as the input for the next flip-flops. And similarly here I have used the 7-segment display to show the output. And similarly in as up counter, here we are going to use the logic 1 always. Now when I run the circuit you see that it starts from 15 and goes to 0 because it is 7-segment display. Here the 10, 11 do not show, but the maximum number 9 shows. You see that 9, it is 9, 8, 7, 6, 5 in descending order. So this is our synchronous down counter which counts from 15 to 0 in 4-bit number. So here is the circuit of our synchronous down counter. So in today's lab we have discussed the registers, counter, synchronous down counter and synchronous up counter, and we have make the circuit of synchronous up and down counter in Proteus and simulate this. So that's enough for today's lab. Thank you.